Welcome to the project brief for the second part of Project 6. And the second part is a bit more tricky as the file name structure of the data is a bit more complex. So we're loading the US baby names by state from data.gov. And also here you should avoid loading the files into the existing folder names by state. So you should avoid to have all files here twice. And therefore it's best to create a new folder and also move the blank notebook here into that new folder. Now as a first exercise, then you should load one file, so the ak.txt file, and ak stands for Alaska, the state. So you should load one file and inspect the data structure. And then in the next step, you should load all files and merge and concatenate all files into one data frame and one file. And here in this example, the glob module will help you to get all text file names in your folder. So first of all, you have to import glob. And then as a first exercise, you should try to find all file names with the following structure. So A, and then the question mark is a placeholder for one single character, .text. And for example, you should get ak.txt and I think two other file names. And then finally, you should find all file names with the following structure in your current directory and save the resulting list in a variable. So essentially, you should find and save the file names for all text files. And this is here the structure. So we have asterisk.txt, and actually asterisk is a wildcard or a placeholder for 0 or many characters. So with this you can find all text file names. And then once you have identified all file names, you can actually load all text file names and merge and concatenate those files into one pandas data frame. And finally, you should create a range index and save the data frame with the columns state, gender, year, name, and count in a new CSV file. So this is part 2 of Project 6. And in case you haven't worked with the glob before, then you can find some hints here below. Thanks for watching and see you also in the solution videos. Bye. In this and the next lecture, we are going to import the baby names dataset by states. So that's the second file that we downloaded earlier. And first of all, let's have a look at our working directory or folder. So it's the baby folder. And here we have the two downloaded zip files and the unzipped files. And now let's go to the second one, names by state. And here we have the Jupyter notebook that we are currently coding in, and we have some CSV or text files. And actually for each and every US state, we have one dataset and one text file containing baby names from 1910 till 2018. For instance, we have here AK for Alaska, then AL for Alabama, and AR for Arkansas. So now let's go back to our Jupyter notebook and let's import Alaska. And first of all, we import pandas, and then we import the text file ak.txt, so Alaska. And here we have all baby names in Alaska from 1910 till 2018. And the most popular female name in 1910 was Mary, with a count of 14. Then we have Annie and Anna. And finally, at the very bottom, we have some less frequent male names in 2018, for example, Theo or Thorin. And also here, only names with a count of equal or greater than 5 are included in the dataset. And we can also see that we have actually no column header or column label. And therefore, we should create one. So we pass none to the header parameter, and for the first column we have state, then we have gender, year, name, and also the count. And here we have the final data frame for Alaska, and in total we have 28,000 rows. So that's one state, and in the next lectures we are going to import all states and actually merge them into one data frame. So hope to see you there. Bye. Alright, this is an introduction to the globe module, and the globe module helps us to find all file names, or more general, all path names matching a specified pattern. So here in the name by state download, there's no simple pattern in the file name, and we cannot simply replace the year as we did before. Instead, the file names contain the official abbreviations of the state names, like AK or AL, and we cannot simply create all abbreviations with a for loop. And unless we already have the abbreviations in place, creating them manually is really messy and time consuming. There must be a better solution, and the globe is the right module for this task. So let's go back here and let's import pandas and globe from globe. And let's have a look into the function globe. So it returns a list of paths matching a path name pattern. And in our first example, the pattern starts with an A here. So the state abbreviation starts with an A. Then we have a question mark, and this stands for a single character wildcard. So to say, this is a placeholder for one additional character. And then we have dot text. And globe actually returns all file names or path names that match this pattern here. And here we get AK text, AL text, AR text, and AZ text. However, we can also apply the more general wildcard asterisk, and this is actually a placeholder for 0 or more characters. So here we can pass asterisk dot text. And now let's get all file names that match this pattern here. And here we have actually all files in our working directory or folder. So these are all states. And I also want to highlight a more special case. So let's go back to our folder. And here we have a subdirectory or subfolder with the name subdir. And let's go here inside. And here we have the two files, 1880 and 1881. And with globe, we can also get file names in a subdirectory. And we can simply do this with the following code. So here we add the subdir, so that's the name of our subdirectory. And then two backslashes, and then the asterisk dot text. And here we get, of course, the two files, 1880 and 81. And as a side note, we can also import those text files into a pandas data frame by using here read CSV. And then we have subdirectory and two backslashes and then the file name. And this works as well. So now let's go back to our names by state files. And let's save all file names in the variable file names. And here we pass asterisk.text. And actually file names is a list containing all file names or path names. So let's have a look here. So we have ak.text, al.text, and so on. And in total, we have here 51 elements for all states. And actually having all file names in one list makes it pretty easy to import all files and also merge all files into one data frame. And that's exactly what we are going to do in the next lecture. So thanks for watching and see you there. Bye. In this lecture, we are going to import and merge all 51 state datasets into one data frame. And we still have saved the list file names with all file names. And now in the next step, it's pretty straightforward to import all 51 files and create for each and every file a pandas data frame. So we create the empty list data frames, and then we iterate over the list file names, so for name and file names. And in each and every iteration, we pass the particular file name to pd.readcsv. And again, we create appropriate column headers or column labels. And we create for each and every file name a data frame df. And we append all data frames to the list data frames. So let's run the cell here. And let's inspect data frames. So this is a list with 51 data frames, and the first one is here for Alaska, and the last data frame for, I think it's Wyoming. And in total we have 51 data frames. And then again, we can vertically concatenate all data frames with pd.concat, and we pass our list data frames. And actually, we want to remove the original row labels, and we simply want to have a range index starting from 0 till whatever, and therefore we pass true to the ignore index parameter, and we create the data frame df. And let's have a look at df. So we're starting with Alaska and ending with Wyoming. And in total, we have over 6 million rows and 5 columns. And in the column state, gender, and name, we have text data or string data. And in the columns year and count, we have numerical data. And we can also see that we have a pretty large data set and data frames. So we have a memory usage of 230 megabytes. And finally, we can also export and save our data frame. And we can create a CSV file with 2 CSV. And the file name is baby names state.csv. And again, we do not export the range index. So we pass false to the index parameter. And finally, we can re-import the CSV file and create a data frame with read CSV. So let's double check this. And here we have our data frame. All right, thanks for watching, and see you in the next lecture. Bye. This is a short excursus on how to save memory with categorical features, and the baby names data frame is a perfect example for this. So we have a large data set with 230 megabytes. And we have actually 2 categorical features, gender and state. And here we have only few different values, or to say very few unique values. And we can check this with nUnique. So in the gender column, we only have 2 unique values. We have F and M for female and male. And we have 51 states. And actually, this isn't really memory efficient, as each and every element in those 2 columns is saved in memory as a string. So we have around about 3 million times the string F and 3 million times the string M saved in memory. And actually, we can save a lot of memory by converting the data type in those columns to categorical. And by doing so in the background, M and F are stored only once. And all 6 million cells are then referencing to either M or F. So let's convert the data types, and we can do this with S type, and we pass a category, and then we overwrite the gender and the state column. And let's have a look at the gender column. And here we can see that the data type is now category, and we have 2 categories, F and M. And now let's have a look also at the memory usage. So far we had 230 megabytes, and now we are able to reduce memory usage by 35% to 150 megabyte. And actually there are pros and cons of having columns with the data type category. So ordered categoricals are really useful, and we might see an example in later sections. And also categorical features can speed up but also slow down your code. And in some situations, categoricals can also cause severe problems and errors. So I'm really careful with the data type category, and it seems to be a great concept, but there are drawbacks as well. All right, thanks for watching, and see you also in the next video. Bye.